Let's now dive into the maths behind double, and that is through Fano planes. Let's define a number n, which is called the order of a Fano plane. I have n plus 1, which essentially translates into number of symbols on every card, and then I have the value n square plus n plus 1, which translates to the maximum number of cards that can be played and the maximum number of different types of symbols that you will need. Let's look at the basic trivial solution where n is 0. Then the number of symbols per card is 1 and the maximum possible cards is going to be 1. This is a very trivial solution. If I just take one card of double and let's say I have a single symbol on it, this connects with every other card of the same symbol. So the number of unique cards that I have with one symbol per card, let's take the example of n is equal to 1. Now in this case, the number of symbols that we need per card are 2 and n square plus n plus 1. Let's look at an example for this, right? Let's say that we have 3 cards with us. The first card has AB, the second card has BC, and the third card has AC. Now, AB connects to BC through B, BC connects to AC through C, and AB connects to AC through A. So the maximum number of possible cards that we can play where the order of the Fano plane is 1, we need 2 symbols per card. I could have done 3, but that's not an optimal game because in double, the optimal game is defined as having the least number of symbols on any given card, having the maximum number of cards such that any 2 cards have one and only one common symbol or logo. Let's look at the next case where n is 3. If n is 3, we need 4 symbols per card and we can have a total of 13 cards. One very interesting thing to note here is that the value of n for which the Fano plane concept applies are all prime numbers. Now 0 and 1 are not prime numbers, but I have used the concept of 0 and 1 as the trivial solution, what is referred to in mathematics, because 0 being we need only one card with one symbol on it. And here I have explained how it works exactly 3 cards or 2 symbols per card. And then we have